हेलो स्टूडेंट्स। पिछले टर्न पर हम सिंपल हार्मोनिक मोशन पढ़ रहे थे और सिंपल हार्मोनिक मोशन में हमने निकाला था इक्वेशन ऑफ सिंपल हार्मोनिक मोशन एंड इक्वेशन ऑफ एंगुलर हार्मोनिक मोशन। दोनों के इक्वेशंस निकाले थे एंड हाउ टू फाइंड आउट द टाइम पीरियड ऑफ द बॉडी which is doing simple harmonic motion, that is t is equal to 2 pi root m by k, and m is mass of the body, k is spring constant, and body is attached to the spring. Then the time period of the body will be 2 pi root m by k. Now our next topic is simple pendulum. If a heavy point mass is suspended, the definition of pendulum is if a heavy point mass is suspended by a weightless, inextensible, perfectly flexible string from a rigid support, then this arrangement is called simple pendulum. Derivation for time period of simple pendulum. This is rigid support and we take weightless, extensible, flexible string. This is point mass. Weight of the body always towards the center of the earth. W is equal to mg, and this angle is theta, and this also will be equal to the theta. Tension in string towards the support, tension always towards the support. A component of mg, weight of the body, is mg cos theta, and another component, this is vertical component, will be mg sin theta. Let L be the length of the string, and if theta is less, the displacement of the body is x, and here the restoring force acting on pendulum, restoring force is the vertical component of weight of the body. The restoring force F is equal to minus mg sin theta. If theta is small, then sin theta consider as theta only, for we know that angle theta is arc upon radius, and here if theta is small, then arc and displacement x almost will be equal, then x upon L, radius of path is L. Here theta is equal to arc upon radius, that will be approximately equal to x by L. So we can write F is equal to minus mg x upon L. Here negative sign is if theta increases, it means angular displacement theta and restoring force are opposite to each other. The direction हम यदि कंसीडर करें इसका तो थीटा अपोजिट डायरेक्शन में पड़ता है और रेस्टोरिंग फोर्स ऑलवेज एक्ट्स टुवर्ड्स द मीन पोजीशन. So both are opposite in direction. So we have to take the minus f equal to minus mg sin theta, and sin theta is equal to theta when theta is very small, and we know that angle equal to arc upon radius, and arc will be approximately equal to x for the small angle theta. So that f equal to minus mg into x upon L. This is our first equation. We know that f is equal to minus kx in simple harmonic motion, and on comparing first and second, mgx upon L is equal to kx, or mg is equal to kl, m upon k is equal to L by. We know that time period of the pendulum is given by time period is equal to 2 pi. Time period in simple harmonic motion is m by k. So here time period of pendulum will be 2 pi root L by g. Here m by k is L by g. This is also time period. Some important points related to the simple pendulum. On increasing the length of simple pendulum, time period increases, but time period of simple pendulum of infinite length is 84.6 minutes. We know that t proportional to root L. On increasing the length, time period also increases, but if length L is infinite, t becomes fixed 84.6. Another point B.
Time period of second pendulum is 2 seconds, and length will be approximately 1 meter, that is 0.993 meter. The third point is simple pendulum perform angular simple harmonic motion, but due to small angular displacement it is considered as SHM, linear SHM, linear simple harmonic motion. Pendulum performs angular harmonic motion, but for a small angular displacement, it is considered as linear simple harmonic motion. Simple harmonic motion means also linear, so we can say it is considered as simple harmonic motion only, not linear. या linear harmonic motion हम कह सकते हैं. As if time period of the clock increases, it means pendulum becomes slower, and time period decreases, pendulum, or we can say the clock, will be fast. If t increases, clock becomes pendulum of clock becomes slower, and vice versa. Key point is, we know that t is equal to 2 pi root L by G. Here 2 pi is constant quantity and G is also constant. So t is proportional to root L, or t is equal to k root L. It shows that the percent change in t, delta t upon t into 100, will be equal to, पावर को हम आगे ले लेते हैं, इसकी हाफ पावर है तो हाफ डेल्टा एल अपॉन एल इंटू 100% change in t when g is constant. Here g is considered as constant. If g is variable and L is constant, g is changing and L considered as constant, then delta t by t into 100, this is change in time period, will be equal to minus, because it is inversely proportional, so power will be negative. तो हम कह सकते हैं कि t is proportional to 1 by root L, और t is equal to k L raised to the power minus half. So change in delta t, change in t, percent change in time period, delta t by t into 100 will be equal to minus half delta L upon L into 100.